Thank you, Cassidy. So Foxtel, as we all know, has been entertaining Australians for more than 20 years. Foxtel runs iconic media streaming brands that we have all come to love, such as Foxtel, Fox Sports, Flash, and more recently, the Hubble streaming device service, and of course, Binge, that I look at so lovingly every day. With the launch of so many brands and services and products, Foxtel's data volumes exploded. Very soon, with a single large cluster running their data platform, they started having issues on workload isolation and resource contention. So in today's session, we'll take a look at how Foxtel not only solved for these challenges, but at the same time set up the foundation for a data mesh architecture. So let's jump in. From an agenda point of view today, first I will talk about Redshift's data sharing capability. Then Simon will talk us about his experience of implementing these cutting edge features at Foxtel, followed by Praveen doing a quick demo to show you how simple and easy is it to use these features in Redshift. And we'll wrap up with a few lessons learned based on our engagement with Foxtel. Redshift sits at the core of Foxtel's data platform. Redshift enables Foxtel to drive critical business use cases such as cross-sell, upscale, personalization of their streaming services, carousel management, in addition to critical daily, weekly, monthly management and BI reporting. With Redshift, it was easy for Foxtel to ingest a lot of data into their data platform and accelerate a lot of analytics use cases and drive business value. Similar to Foxtel, and for tens and thousands of our Redshift customers find that with Redshift, it's easy to ingest data using features such as zero ETL. With zero ETL, you can seamlessly ingest data from your S3 data lake, from streaming services such as Kinesis and Kafka, and from operational databases such as RDS and Aurora. Redshift also natively integrates with data in your data lake, including data that might be stored in transactional data lake formats such as Hoodie, Iceberg, and Delta. So as I mentioned before, with such a huge increase in volumes and the single large Redshift cluster, Foxtel started facing issues on workload isolation and very soon started missing 50% of their BI and reporting SLAs. So a key question that they came back to us with was, what's the right architectural pattern to scale this infrastructure? We worked with Simon and team to optimize their existing cluster first. We worked backwards from their requirements and did a formal review of their current state of architecture. Redshift provides three options for workload isolation and workload management. The first is Redshift's auto workload management, which is inbuilt into Redshift. With auto WLM, Redshift uses sophisticated AI and machine learning algorithms to dynamically manage query concurrency and memory allocation across its workload queues. The second option is Redshift's concurrency scaling feature, where Redshift detects and transiently adds additional node capacity to cater to increasing and spiky workload volumes. And lastly, with data sharing, two or more Redshift clusters can share data amongst themselves to fully isolate workloads amongst those clusters and enable our customers to manage those workloads independently. Redshift data sharing enables Redshift clusters to share data amongst themselves without moving or copying the data from one cluster to another, without having the need to build complex ETL pipelines. Redshift data sharing works across provision and serverless clusters, or any combination thereof. And it also works if the cluster are in the same account or different accounts, or also across different AWS regions. Since the data is live at all points in time, all the consumers of the data get access to the same consistent, up-to-date information across these clusters at all points in time. This has proven to be a really widely popular architectural pattern to improve performance and optimize costs. And today, more than 10 million queries are run using Redshift's data sharing features on a daily basis. So let's take a look under the hood how this works. Redshift's third generation architecture, the RA3 node, has complete separation of storage and compute. The storage layer in Redshift is actually powered by S3, but it's fully managed by Redshift. It's called as Redshift Managed S3 Storage, or RMS for short. As the producer cluster is writing and committing data to this RMS layer, the consumer cluster is able to access the RMS layer of the producer cluster to serve queries and respond to workload requirements on the consumer cluster. So as you can see, with data sharing and with the RMS layer, the consumer cluster and the producer cluster are completely isolated from each other. We have evolved this capability even further. This re:Invent, we announced Redshift's capability for write data sharing. So with write data sharing, 2 or more consumer clusters can write back to the same producer cluster. So with read and write data sharing, you now have the capability to share data for reading and writing across clusters, across serverless or provision clusters, without having to move or copy the data from one cluster to the other. And these clusters might be across accounts or across regions to cater to your workload isolation and price performance optimization requirements. With this, I'll request Simon to come on stage and talk about his experience of implementing these features at Foxtel.
Okay, so thank you for that, Amit. So let's continue with Foxtel's data sharing journey. So I'd like to start by taking you back to 2018, which is when Foxtel first introduced its first streaming service, which was KO Sports. Now, prior to this, the Foxtel data team had realized that our current data infrastructure would not be able to support the large influx in data that would result from introducing 3 new streaming services into the Foxtel portfolio. So consequently, we set about building a greenfield data lake. We call this data lake Gene. Now, Gene sits atop of AWS. It's cloud native, but at its very core, it has a Redshift cluster. Now, over the next 2 to 3 years, Foxtel introduced both the binge and flash streaming services, and these were promptly onboarded onto the Gene data lake. However, it wasn't until 2022 when the Gene data lake actually became the data lake for the whole of the Foxtel business. So as you can imagine, at this point, there was a large increase in both the volume of data and the number and type of applications that the Gene data lake was supporting. And it was around about this time that we also started to open up discussions with AWS in terms of how to use Redshift data sharing to resolve some workload contention issues that we were facing with some of our critical business services. And then just a few months later, we released our first data share, which was the real-time data share. And then if we fast forward to late 2023, we deployed our second data share, which is our Labs data share. Now, the Labs data share is aimed more towards our developer community. And then, as I'm sure many of people have seen, just a few weeks ago, Foxtel launched Hubble. Now, Hubble is a streaming device that really fuses together the very best in online streaming, global and local streaming services, live TV, live sports, as well as news feeds into a seamless user experience. And we're already seeing an uptick in the volume of data supported and processed by Gene as a result of the introduction of Hubble. So what does the Gene data platform look like? It's essentially a fairly typical 3-tier data lake system consisting of a landing platform, sourcing tier, and transformation tier. Now, we have many different sources which feed the data lake, but it's not until the data actually hits the transformation layer, which is where it's curated and it's given its business context. So it's also in the transformation layer that the data first hits the Redshift cluster. Now, within the Redshift cluster, we also extensively use Spectrum. And we use Spectrum to go back and access the data that sits in our S3 sourcing layer. Now, most of the transformations within the Gene data lake are performed by Apache Airflow pipelines. And we actually have over 7,000 pipelines that run daily within the Gene data platform. Gene's currently managing about 3.6 petabytes of information, and this is growing at a rate of about 200 terabytes per month. Now, the Gene Data Platform supports literally hundreds of different use cases for the Foxtel business. Amongst these are being personalization. Personalization allows us to make world-class recommendations on what content should be viewed next by our subscribers. And we also have content acquisition, where information within Gene Data Lake is helping our content team put bids together for buying future content. And this content could be sporting content as well. Now, our use cases are categorized into one of 5 different workload types within Gene. The first of these workload types is ETL. Now, I've already described the ETL workload, so I won't go into any more detail here. Then we have the real-time dashboards. Now, real-time dashboards are absolutely critical to the Foxtel business, because they present near real-time information to our executives. So it allows our executives to make agile business decisions in a changing business environment. So obviously, the timeliness and the accuracy of the data within these dashboards is absolutely key for us. We also have a number of BI and reporting applications, and these really support our day-to-day business, running from kind of tactical-like decisions all the way to long-term strategic-type decisions. We have a set of AI workloads, which personalization is obviously a key component, but it's certainly not the only component that we have. And then we have our developers and also our data scientists. And these guys are essentially developing new applications for the Foxtel business. Now, initially, when we first released Gene, then this single monolithic Redshift cluster worked well in supporting all these different workloads and use cases. But as we added more and more workload onto the Gene platform, and also added more applications, different types of applications, we started to see an increase in workload contention. Now, the workload contention was essentially manifesting itself as inconsistent performance within our business critical services. And this really impacted everything from our ETL service to our BI and reporting, and probably most critical, our real-time dashboards. With the real-time dashboards, they were no longer presenting that real-time or near real-time information, and so our executives were no longer able to make those agile business decisions. And when all this is combined, we're essentially seeing an increased churn across our subscriber base. So it's essentially impacting the bottom line of the Foxtel business. We also found it increasingly difficult as more and more applications were onboarded onto the Redshift cluster to carve out resources within the cluster to assign them to our most critical applications. That became somewhat of a contentious issue. And the Gene Data team, we also have one eye on the future. And we really want to enable the users of the data platform to be able to commoditize data, to build data products. And with that in mind, the architecture for enabling this is a data mesh. And we really had a feeling that this single monolithic Redshift cluster was somewhat restrictive to enabling such a data mesh environment within Foxtel. So this is when we started our discussions with AWS, and we worked with Praveen and Amit. And we're really looking at how Redshift data sharing could reduce some of the contention and improve reliability of our most critical workloads. So we started with the real-time dashboards, because this was our most critical workload at the time. And the process is really quite simple. We simply carve out a new cluster, which will be our data share consumer cluster. Now, this cluster is where the real-time dashboard workload will run. It's actually smaller than our main ETL cluster. Our main ETL cluster then becomes a data share producer cluster, and we only share the data that's absolutely necessary for the workload to run from the producer onto the consumer. And then we simply move the workload over from the main producer cluster onto the ETL cluster. And once it's running, onto the consumer cluster. Once it's running on the consumer cluster, it's totally isolated from any of the other workloads that we have running across the whole of the Gene environment. Now, because the real-time dashboards are very time critical, we also did extensive performance work at this stage in the project. And we're really focused on 2 key areas here. We wanted to understand whether or not running our workload on the data share consumer added any additional overhead in terms of CPU, memory, disk, I/O, etc. So whether or not it added any additional overhead onto the data share producer. And we actually found that there was no additional overhead on the producer as a result of that. The second key area was comparing the performance of running our workload on the DataShare consumer with running it on a totally dedicated Redshift cluster with exactly the same spec as the consumer. And here we were looking to find out whether or not there was any additional lag or performance degradation added as a result of running a workload on a DataShare consumer. And again, we found out that there was no lag introduced here. So I think kudos here goes to the AWS engineers who've obviously thought long and hard about how to implement this separation of compute from storage. And really data sharing it really highlights how well that is architected. So we released the real-time data share in 2022, and essentially since then, this workload has just been humming along. We really don't have any issues with it. However, it didn't really resolve any of the issues with the workloads that remained on our main ETL cluster. We were still seeing inconsistent performance here. And we weren't really expecting it to resolve those issues because we knew most of those issues were coming from our developers who had the ability to issue ad hoc SQL against our main production cluster. Every now and then, one of these pieces of SQL would just become a huge resource hog, and the cluster would slowly grind to a halt. So with that in mind, in late 2023, we released our Labs data share. Now, the Labs data share essentially provides a safe environment for our developers to build and test their SQL. They have access to the real production data, but because the SQL is running on a data share, they know that they're not going to impact anything that's running on our production cluster anymore. Now, we're still in a phased migration process from our main production cluster onto the ETL, onto the Labs cluster, but even in the last couple of months, we've seen a remarkable improvement in the consistency across our workloads. So with that, I'd like to hand over to Praveen, who's now going to take you through a demo and really show you just how simple it is to create a data sharing environment. There you go.
Thank you, Simon.
Cheers.
Thank you, Simon. So the intent of this demo is to show you how simple and easy it is to get started with Redshift data sharing. But first, the setup. At a high level, this is very similar to Foxtel environment. On the left-hand side, what you see is a producer environment that's going to serve the ETL workloads. And on the right-hand side is a consumer environment. Think of this as you're going to run ad hoc query and data lab workloads. And so the way it works is the data is being managed and produced by the environment on the left, whereas analysts would come and run query on top of this data using the compute that's dedicated to them on the consumer environment. The steps are really simple to configure, as you'll see in the demo. So on the producer side, you go and create data share. You go and add your schemas and tables that you want to share with the consumer environment. And then one final step is granting access of that data share object to the consumer. On the consumer side, you go and create an external database that points to the data share object, and that's it. Then you can start running your SQL queries. So let's see this in action now. So I'm in Redshift Query Editor version 2. As you can see on the left-hand side, I have got two serverless endpoints. The one at the bottom is for ETL cluster. The one on the top is your ad hoc query workload. Now, both these endpoints have its own dedicated compute. So what I'm going to do is I have a table that's being managed by the ETL endpoint, which I'm going to share with the consumer environment. So I'm going to run a simple select star on this table to show you what that looks like. So this has about 100K records, and this is what it looks like, right? So after that, let's set up the data sharing. And it's as simple as running a few SQL statements. So one of the first step is create data share object. So I'll do that. Then I'm going to add a schema that includes that table to this data share object. And then I'm going to add the table itself to the data share object. All of that is happening on the producer side. One final step on the producer side is granting access of this data share to the consumer endpoint. And so I'll be using the globally unique identifier ID of the Redshift serverless endpoint of the consumer environment. And that's it. Now let's hop onto the consumer tab. So I'll execute this couple of SQL statements. Now the first one is really to tell you what inbound and outbound data shares that you have access to. So as you can see, the producer data share is appearing now. And then I'm going to create an external database that points to the data share object that I just created on the producer. And that's it, right? So after that, you can think of the analyst would come and start writing their SQL queries, which is running on top of the data that's been created by the producer environment, but it's using its own dedicated compute. And that's how you get true workload isolation. With that, I'm going to hand over to Simon to take you through the learnings from this implementation.
Okay, so thank you for that, Praveen. So I'd like to spend the rest of the session now talking about the learnings that we had within Foxtel as we implemented the data share environments. So the first thing, I'm not going to spend too much time here, but don't try to boil the ocean on your first data share. Make sure you have a self-contained workload. There's a limited number of shared objects, and it's a well-defined success criteria, because you really want this first project to be a success. This second learning here is about making sure you have a workload that you can test on the data share consumer with. And this is a step that's often missed out by people. With the real-time data share, we actually captured the workload from, as it was executing on our main ETL cluster, and replayed it on the data share cluster. And this gives you a really good representation of exactly what SQL is being issued on your cluster. When you're actually testing against the data share consumer, you find things like missing objects that you haven't shared, views you haven't created, permissions that need to be granted. But probably most important is to create an optimal and the most cost-effective Redshift configuration in terms of what nodes and type of nodes are actually needed for this data share consumer. Now, you also have to really pay very careful attention to what objects cannot be shared. So I previously mentioned that in our Gene data lake, we make extensive use of Spectrum to go back and access data that sits on our S3 sourcing layer. Now, unfortunately, Spectrum is not currently supported by Redshift data sharing. So if you want to access Spectrum data on your consumer cluster, you need to recreate that external Spectrum schema on the consumer cluster. Now, that's not too much of a problem, since it's only a simple single SQL statement, and then you have access to all the tables within that Spectrum schema. However, within Gene, we make extensive use of views to access our tables in Spectrum, and some of these views contain user-defined functions. Now, because these views and functions are defined on top of tables that cannot be shared, then also these views and functions cannot be shared. So you also need to recreate these objects on the data share consumer. So here you can see probably you may finish up in an environment where you're creating and managing tens or maybe even hundreds of objects on the consumer. But it also introduces an interesting synchronization challenge. So what happens when a new view is created on a Spectrum table on the producer cluster? Then of course you can't access this view on the consumer cluster until it's created. So there's an synchronization challenge here on how to synchronize the consumer and the producer, and we'll see how we do that in just a couple of slides. Now, you also have to think about how to manage complexity for your users within a data sharing environment. And we did this within Gene by using consistent object names and creating views. So I'll take you through an example here. So in this example, we have an object, schema1.table1, on our producer cluster. Now, when you share this object with the consumer cluster, you access that object using a three-part name on the consumer cluster, as you saw in the demo from Praveen. The first part of that name is the data share name, .schema name, .table name. So there's obviously some inconsistency here between how you access this object on the data share consumer using a three-part name and how you access it on the producer using a two-part name. So within the Gene data environment, we created these views on the data share consumer to provide consistent object names. Now the view is simply named the same as the original object. So in this case, schema1.table1, and it's simply created as a select star from the three-part data share name. And once this has been created, you can use the two-part name to reference this object, whether it's on the data share consumer or the data share producer. It also greatly simplifies application migration. In terms of the real-time data workload, when we migrated the workload, we didn't have to change any of the SQL within the workload because we'd created these views which allowed us to use two-part names. But it does also introduce a similar synchronization problem in terms of what happens when a new object is added that needs to be shared. Now, the way we solve these synchronization issues was to create a Gene data share service. Now this data share service takes as input a single configuration file, and this configuration file defines the complete data sharing environment, everything within the data sharing environment. It's created by a member of the data team who gathers the data requirements, or gathers the requirements, and once it's been merged and reviewed, then the data share service generates all the SQL to create and deploy that environment amongst the producer and consumer clusters. Now, if we integrate all this, well, we integrate all this within the Foxtel CI/CD process, and couple this with the fact that we also have a test workload, we're able to churn through many different iterations of a data share configuration to find the best one which suits our users' needs. Now, because we have this configuration file, it's also able to reconcile differences between the producer and consumer environment. So if, for example, a new object is added to the data share producer, the configuration file knows that this object needs to be shared and that, for example, a two-part view needs to be created on that data share consumer. So it uses the configuration file to synchronize the two environments. Now, so far, we've really talked about how Foxtel have used data sharing in a workload isolation context. As our data engineers were going through the process of deploying these systems, we actually realized that actually data sharing would be ideal as a foundation block for a data mesh. And the chart you see here is a proposed architecture we have within Foxtel for implementing that data mesh. So our main ETL cluster, again, is the producer cluster. Within each of our business domains within the data mesh, we have a consumer cluster. And we only share the data from the producer cluster to the consumer cluster that's necessary for that particular domain. So we already have an added level of security here. Now, because each domain has its own consumer cluster, it's totally isolated from the impact of any interference from the other domains. And plus, if the business sees fit, they can start to cross-charge for the usage of these consumer services. Now, once a data product has been built, it's published onto a global catalog. In our case, that would be the AWS Glue catalog. And then it can be consumed by any of the other domains, business domains. So hopefully you can see from this just how data sharing can really fit into both a workload isolation and also a data mesh context. Now this last slide really just covers the topics that the learnings that we went through over the second part of this presentation. And with that, I'd like to hand back to Amit for the closing remarks. Thank you.
Thank you, Simon. Some great learnings there from the experience of implementing this at Foxtel. So our customers have been using Redshift's data sharing capability for a number of use cases, right? Key ones are there around workload isolation, price performance optimization, but they're also using this for enhancing cross-group and line of business collaboration, implementing chargeback mechanisms for the compute that is used by, say, a line of business against a central IT cluster, or improving developmental agility by easily building dev test environments by sharing data between production and dev and test environments, and obviously, as we saw in the case of Foxtel, building data products and laying the foundations for a data mesh architecture. If you want to know more about Redshift and learn more about Redshift or any of our services, visit skillbuilder.aws. Learn at your own pace and get access to over 600 courses, all developed by AWS experts. That concludes today's session. We would love to hear feedback on what we presented today. Do let us know your thoughts in the AWS Mobile Summit app. Thank you so much.
Thank you so much, mate. Really, really appreciate it.